Today we're going to focus on a program uh, that Mike Parkowski, I'm just going to turn things over to him from the DSWA, Delaware Solid Waste Authority, has been working on for several years and had a pilot project that I'll put the link in the chat so you can check it out if you haven't already. But Mike's here to sort of pick up on the results, I guess, of that study and where we might go from there in terms of fostering composting on specifically for large institutions. And so I'll just turn things over to Mike and let him tell you more about it and where it's going.
All right,
Thanks for being here, Mike.
Yeah, thank you. I've got a chance to meet a lot of you at the MRF on the tours, and we talked about this a little bit. So I wanted to, Dee asked me to come and give a presentation. And so, we did a partnership with University of Delaware. We asked them to help us with a report. We started it around 2019, and they published that final report last year in September. And like Dee said, she'll put the links up for the report. But the whole idea, the concept is to use these biodigesters, which is not exactly the same as anaerobic digester, but it's something that breaks down food waste, and it's really meant for on-site decomposition. And what I mean by that is you would install this machine at a commercial entity, a restaurant, a grocery store, a cafeteria, and it would use enzymes to break down the food, and that would be done at the location as opposed to loading it into a truck and driving it to, say, an anaerobic digester system or a facility that's located some distance away. And so what would happen is when the food waste goes down, it goes into the sewer and it goes into the wastewater treatment facility. So this kind of gives you the timeline. We also, BioHigh-Tech is a company that makes these types of digesters, and they're not the only one, but they're who we've been dealing with primarily because they had 2 units already in place at the University of Delaware Caesar Rodney Dining Hall. So we got to see how they worked firsthand, and we got to experience that. And then they also helped with the study in supplying University of Delaware team with a smaller unit that they could use in their lab and conduct their test on. And then later, they also supplied a unit to Grotto Pizza on Main Street, which they did. So you can see that in the study. And then what's happening right now is we're starting to work with Keep America Beautiful as maybe. So originally the thought was we were going to try to do grants to have businesses apply to get one of these units, and DSWA would give them money to get a unit installed. And we thought we would try to process those grants through RPAC. That was the original thought. RPAC is the Recycling Public Advisory Council, which Dee and I are both members of. But it seems like that might not be the best way to do it. So I reached out to Keep America Beautiful, which is another organization DSWA has close ties to. As a nonprofit, they could administer grants. And so that's one of the reasons we're working with them. So what is a biodigester? This is kind of what it looks like. They don't all look the same, but this is kind of a basic model. This is kind of similar to the one that's at University of Delaware. And you can see that big hatch, that's where the food goes in. And then it's got a series of drains and pipes that hook right into the drains of the facility. It's got a compact footprint. It's not terribly large, so it can fit in most commercial kitchens. That particular one is designed for medium to large volume of food. It can process up to 600 pounds of food per day. And it comes with an interface so that someone offsite can monitor the material that's going through the machine. And BioHigh-Tech provides that type of service. But we'll get into a little bit more about them coming up, because there's some issues right now with the finances of that particular company. And so that's why we're also looking into other companies. We don't want to be tied into just one brand or one name. So since there's other people in this market, the problem right now is a lot of these companies exist, but they're mainly in Europe. So there's not a lot of American companies doing this type of work. So kind of what how it works, I kind of explained it. It uses enzymes to break down the food. It liquefies the food waste, so it makes it almost a watery substance, and then it's transferred through the sewer pipes to the wastewater treatment plant. And of course, the benefit of that is it increases landfill diversion, so the food waste is no longer getting thrown in the trash in the dumpster, and that's not ending up in landfill. It's ending up at the wastewater treatment plant. And so, one of the questions that we had was, well, how will that affect wastewater treatment facilities? That was our biggest concern. We didn't want to solve one problem and create another problem for somebody else. That wasn't our goal. So that's why we really asked University of Delaware to do that study for us, so we could figure out, how it's going to affect the wastewater treatment plants specifically. And as you can see in the report, I think it's pretty favorable that it's not going to have a huge impact on the wastewater treatment plants, and they seem to be willing to deal with it. And there's some reasons to that. So one of the things is it's going to, at a wastewater treatment plant, specifically the one in Wilmington, has an anaerobic digester system in it. So that material going into wastewater will actually go through their anaerobic digester and generate some energy that they can use to dry sludge, which they have these dryers, these heaters that heat up the sludge and dry it so they can move the sludge out. And having that material in the wastewater treatment creates gas, which creates energy, which they can, collect and burn. So some of the other big benefits are, if you guys can remember back, we had a very large food waste composting operation in Wilmington called Wilmington Organics. It was down near the river, and it generated really bad odors. And I mean, there was some of it was mismanagement for sure, but it's been my experience, and I visit literally, I don't know, probably 50 to 60 different large scale food waste operations across the country, and actually in other countries. And they all generate odors. I mean, I think that's one of the things that that people have to understand. There's no way to do traditional composting on a large scale without generating odors. And it's one of those things where you can do it right and you can have minimal odors, or you could do it wrong and you can have really bad odors. And I think that was kind of where we fell with Wilmington Organics. And so that's a benefit, that you don't have to have that. And then the other big advantage is trucks, less truck traffic. So this material will be running through sewer pipes, so you wouldn't have to haul it in a truck, which is the traditional way that all food waste gets transferred to large scale composting facilities. So wherever it's coming from. And in Wilmington's case specifically, they were taking a lot of food waste from New Jersey, and so you had from northern New Jersey, so you had food waste on a truck from almost New York City coming to Wilmington and then being processed. So that's not really a great solution, right? Because emissions are probably are one of the worst things that we've got going for air emissions. So I think from that perspective, it does provide us it's definitely a big benefit to it. So what are some of the roadblocks? So there's cost involved with these units, and so that's why we're looking at the grant program to kind of get them started, because a company would be like, all right, well, you want me to install this thing, how much does it cost? And they can be expensive, and the bigger units can run $75,000, $80,000 and up. And so there's some cost to get in. And then there's the cost of maintenance, the cost of the enzymes. There's so that's kind of where we're at to say, all right, we're willing to help the with grants get this system in if the company that receives the unit is willing to pay for the upkeep and monitoring of it. Training for staff, that's really important. So this is one of the biggest, if you do read the study, you'll see with grottos, when they put the unit in grottos, one of the biggest roadblocks is getting the staff to use the machine the right way, because you can't just put anything in there. You have to put specifically food waste, and you have to put food waste that's not in packaging, and you can't dump so what happens a lot, I don't know how many people have ever worked in a restaurant, but I have, and I'll tell you what happens is when a server clears the table, there's all kinds of stuff in with that food. And so they go to the trash can and they dump everything in the trash can. And a lot of times that includes knives and forks and baskets and salt and pepper shakers and you name it. And what you don't want to do is put any of that stuff into the digester, because it will ruin it. So it has to really just be food waste. So there is some training that's involved with that. And then, of course, the other thing was, how is it going to affect wastewater treatment facilities, which, like I said, that's what the study was all about. And at the end, we do have Michael Chases is here from the University of Delaware, who worked on the report, and I think another member of the team. So they can answer some questions if you have any about that, because they know way more about it than I do. So what did the research lead it to? It basically told us that these machines effectively liquefy the food, which is what we wanted to do. So we know it works. It works under a variety of food waste compositions. So it's not like it only works on salad. Like that's one thing that we were really concerned about as an organization, because a lot of anaerobic digestive systems are very fine-tuned. And what I mean by that, if you have a homogeneous waste of food waste going into an anaerobic digester, it works great. But when you put in like salad for a bit, and then you got carb like bread, and then you've got like ice cream, and then you've got like meat, all that stuff reacts differently in an anaerobic digestive system, and you have to adjust the system as it goes through. So most wet anaerobic digestive systems try to put a homogeneous stream of food waste into them to maximize the amount of energy they're going to get and get the most digestion of the food and most breaking down the food. These machines really don't have that problem. So you could put in all different varieties of food waste and they seem to break it down pretty well. And then the last thing that well, not the last thing, there was many things, but one of the big things was the discharge to sewers was an effective solution to divert food waste from landfills. This was all conclusions from the study. And so, now we're looking at how can we implement this program. So we want to identify target facilities. We need to get out and solicit grant applications, because they're not just going to come to us. We have to get out there and get the word out and, promote this to the company that we want, and also, convince them that why this is a good idea. And there is some savings that can be obtained by the company through less fees for waste. So if they're being charged by their waste hauler by how much waste they generate, and now they're putting less material in their dumpsters, they're going to get charged less. So there is some advantage to the facility, but there, like I said, there's also those roadblocks, there's the trash, the training of the staff and things like that. So, we have to do some salesmanship here. We have to get them on board. And then another big piece of the puzzle is monitoring the progress. So we want to know how much material are we diverting, because that's important. We want results. So who are the target facilities? We're looking at these specifically because they are the larger generations of food waste. This really works on large scales. This is not something you'd want to put in someone's house. It's just too big. It'd be a really waste of money unless you really have a lot of money to spend on it. I would not recommend putting one of these in your home. So, but these are the, assisted living, colleges, university, which we already have that at UD. Prisons are like a great place where there's a lot of food waste. Schools, school cafeterias, and hospital cafeterias. So these are kind of the target things. And as results go, they would be what we're looking to capture is, we know that we get about roughly 78,000 tons of commercial food waste to landfills in Delaware. And we also know that that's unpackaged. So that material is not the packaged material. It's not the stuff that you get from like a store that's already, that's people threw away, like that's in the box or in the plastic wrap or whatever. This is just unpackaged food waste, which is our target. So we also know there's another roughly 50,000 tons that come in that is in packaging, and that really would not be captured in this program. So there'd be a need still for that type of material, but there are a lot of technologies out there right now that are focused on depackaging of food waste, and there's some depackaging machines that are in use, and that would be really another aspect of study that DSWA would look into before implementation, only because there are some issues with contamination in the depackaging side. So we're really focused on the cleaner material and getting that out of the landfill, because it's kind of the low-hanging fruit right now. So with that, I think everyone knows I like to have conversations, so I just thought it'd be best to kind of give you that overview. I don't know if Mike or anybody from UD wanted to just add anything to that before we take some questions or conversations, but I'd invite him to speak.
Sure. I want to acknowledge Rachel Birch is on the line. So she's a PhD student of ours who's really been heading up this research for the past 4 years, and thank DSWA for partnering with us. It's been a great project. I'm really a bridge engineer actually, but of all the things I've worked on, I teach sustainability at UD, serve on their sustainability council, and also on the Delaware Sustainable Energy Utility. Out of all the things I've worked on, this has probably been the one that's gained the most interest, and I'm really glad to see Rachel and I are team teaching 100 engineers this semester sustainability, and I was saying how great it is to see it translating into something. So I just add, we did, as I put in the chat, we have partnered with Tower Hill to do a pilot as well, and as someone mentioned in the chat, it's actually Rachel's working as turning some of that into an educational model for Tower Hill. We have 3 teachers who we funded this summer to come up with lesson plans, and we'll be trying to get that out to the community about how you can use the science of the digester, the biology, the chemistry. The students in Tower Hill know that they're dumping their food into a bin that's going into the digester, so they're very aware of what's going on. It's really exciting for them. Their board is really excited about it, and so it's also a teaching. So I think we all know in the field of sustainability, I think the biggest impact there is probably going to be just teaching hundreds of students about the idea of how we deal with our resources. When Mike came to us and said we have way too much food waste filling up our landfill, and we know in Delaware we have limited landfill space, this seemed like a great option. Rachel's work now is translating into actually taking the digestate, and rather than flushing it down the drain, we believe that it is pre-processed to the point where it's more effective in an anaerobic digester than it would be if you just put food waste in. So that's our next set of studies, is trying to get biogas out of it. But it certainly, for many people, is a great option to eliminate having to bag it, put it in the trash, end up in the landfill, possible workman injuries and things. So it's been interesting, and we've learned. I think we'll just have questions, but we're here we can help Mike answer things about the installations, how it works, what are the drawbacks. And I put in the chat, it's interesting, there was a connection between this company, Earth Biotechnologies, they call themselves EBTech. They've been working with BioHitech, and as Mike said, BioHitech's been, I guess, sort of bought out by an international firm, so they're in a transition phase, but EBTech is nearby. They sell these digesters. There's a whole bunch of them up at Lincoln Financial Field, so they're using it. So, you know, I think if the demand comes, there will be supplies for them, and it's an interesting solution for food waste that certainly prevents it from being trucked to a landfill and just dumped where it's not really useful. So I think the real technical things Rachel can handle, but why don't we open up for questions and see what you have?
And I saw in the chat that someone asked how often 78,000 tons of unpackaged food waste is per year, and it's all Delaware landfills, just so you know.
Mike, can you just clarify for me, what exactly do you mean by unpackaged or
So-
versus packaged food?
Yeah,
Like-
so packaged food versus unpackaged food in the waste stream. So when we do our waste characterization study, we sort the different types of waste, each type of waste. And so food that is loose, like not in a box or not in plastic wrap, is just unpackaged. So if you took, like if you went to your trash can, your trash bag at home, and you had a half-eaten salad and you threw the salad out of your bowl into the trash can, that's unpackaged food waste. But if you had a half-eaten box of cereal and you threw the cereal in the box with the plastic wrap around it, that's packaged food waste. So those are the distinctions that we use. So there's more unpackaged than packaged, but there's still quite a bit of packaged food waste that we get. And that can be anything from, food that's, in a wrapper or in, especially when it's plastic, that's a much harder thing to deal with on the digestion side.
Thanks. Okay. I know there have been some other questions in the chat, and I think we're a small enough group that if maybe if you want to raise your hand, Tree, I see you have your hand up already. Maybe we'll just you can unmute and ask your question directly rather than us trying to go back through the chat, because we've covered a lot of territory in the chat already.
Thanks, Dave. And Mike, this is a great presentation. I appreciate it. I just have 3 questions. I don't know if you want me to throw them all out at the same time and then you can answer them one by one. I'm a little unclear on the difference between a biodigester and an anaerobic digester. Could you explain that difference? That's one question. The second question is, you were talking about there's a cost savings and it's probably still in limbo, but if there could be an argument, you have an economic viability argument. And then the third question is, what food can't you put in the biodigester?
Okay, so the main difference, so there's anaerobic digestion, just means there's no oxygen in the breakdown process. And then aerobic digestion, or what a biodigester is generally, in this case, is aerobic. So it's got oxygen in the process it's breaking down. There's in these on-site composters, they're not exactly the same type of as an anaerobic digester, because an anaerobic digester works more like your digestive system in your body. Like it moves really slowly through the system and it breaks down over a period of time. It's not instant, it's not really fast. This is where we're in the high-tech, or I should say in biodigesters that are on site. They use enzymes to help speed up the digestion. So it breaks down the food faster. So it's happening quicker, and it allows them to load the food each day. And then by the next day, the food is into this liquefied state. Whereas an anaerobic digester might take a longer period of time, and it moves through a track like a channel almost that goes through through the system. Now there's other types. There's dry anaerobic digestion, which is slightly different, which you would put it into a garage and you would heat it with intense heat to break it down. And that's also a little slower process, but those are done on bigger scale. So much more waste goes through those systems. They're much bigger. Like some of them are as big as like a silo at a farm, or even, like I said, like a garage. Like in California, their take has been to use anaerobic digestive facilities. They have wet and dry facilities, but they ship the food waste from all over the place to a central location and then load it into these facilities, either a garage system or, like I said, like a silo system. So those are the two biggest differences. The question about the cost, were you, so just say that again, like what was the?
You were talking about there can be a cost savings, and
Yeah.
in the few things that whether it be at Cesar Rodney or at Grottos, were you able to assess an economic viability for having it?
Yeah, so I would say the cost savings aren't going to offset the cost of the unit necessarily, but maybe over time. And I don't have that time frame, but it would take a while to recoup, because there's also there's maintenance cost that take over time, but it will reduce the amount of material in the waste stream. But if that's the only thing you're doing, you're still going to have waste, and you're still going to have to pay someone to come pick it up. And so the reduction might not add up. And then I maybe you should have done one at a time, because now I can't remember what your third question was.
Well, it's good. Maybe I have to know if I can remember it as well. So
But
yeah.
well, you said you wanted to know what was not in, what was
Yeah,
not.
exactly.
Yeah,
What's
what
not in
doesn't
there.
go in. So typically,
Chicken bones, large
yeah,
chicken
bones are bad. For some anaerobic digestions especially don't want certain types of meats. But I think for these programs, we found, and Mike, maybe you can chime in, but like we found most of the material was good. I mean, there really wasn't anything that didn't break down very, very well.
Yeah, Rachel, do you want to comment on what things you found problematic? Pineapple
Things
cores?
things like raw meat gets pretty gross in there if you put large quantities. Pineapple cores, the insides of corn on the cob, those kinds of things aren't as biodegradable, but there's really not a ton of things that you can't put in there. I mean, even if you put the pineapple top in there, it'll just spin around in there for a really, really long time. Eventually it would break down, but it's an issue of space then. You don't want to take up your whole digester with pineapple tops that are going to sit there forever.
Okay, Bridget, if we covered trees questions, you're up next, I guess.
Thank you, guys. This has been really informative. So my question is, sorry, I was writing it down so I could remember it. I worked for a period of time with the Philadelphia Public Water Company. And so I'm just curious, would there be a limit on how much our water pipes, wastewater treatment plants could handle with something like this? So if it became really, really popular and took off, and all of the large cafeterias in the area were adopting this, is there kind of a limit to what they could handle and successfully manage?
So Mike, do you want to touch on, because the study did a pretty good job of identifying that.
I think we're way away from that,
Yeah.
but it certainly is, if everyone, in some sense, it's almost like an industrial size garbage disposal, and it does add organics. As Mike said, though, a number of the treatment facilities actually would like more organics in there. So, if a ton of people were doing it and it was all concentrated, although, it takes time to get there. So I think we're so far away from that, but the bigger issue we were worried about actually was the fats, oil, and grease that could get in pipes, and to make sure that that was not clogging up the system. So that was something that we studied. We think we're pretty far away, but eventually if it did become pretty prevalent, that is something to consider. And there's also been a teeny bit of an issue I will just say that while the treatment facilities would be happy to have it, it does mean more treatment for them. And then the question becomes, are they going to charge for that? You know, it's an asset for them. They can use it. They can get their anaerobic digesters working. But if they went to you and said, your waste stream has got a lot more organics we have to treat for, so we're going to charge you more to do it. Again, I think we're so far away from that, but that could be an issue that they would say, we now have to do more treatment on the facility, therefore we're going to charge you more.
Right.
More
And I
so.
just want to be clear, like, we're not advocating that we have
Right.
these at every single restaurant, right? It has to meet a threshold, and we have to identify what that threshold is. And, we're really looking for large generators, and we feel like there's probably like, maybe 25, 30 large generators in Newcastle County that are basically supplying, 50 to 60% of the food waste. So if you can identify them and you can put the system in, and if we're only talking about 70,000 tons, it's not going to overload a wastewater treatment facility.
Right.
Sure. Now, if every single household had one of these, then maybe you'd be in that ballpark. But again, these aren't built for household use. So, I don't think that would ever be an issue.
And honestly, for instance, for us in Newark, we're hoping actually that we can eventually put an anaerobic digester on site on campus, and then we would actually like to collect this, which would be nice. You can't transport it too far, but if you collect it in drums from restaurants, as Mike said, it's really for larger entities, but that could contribute a lot to reducing what goes in landfill.
Or if you had an anaerobic digester that you could pipe to.
If we could
you
pipe
had
to
a
it,
really,
great. Yep.
if you had a really large, so that's like, so people don't know, like at the landfills, we generate what we call leachate. And leachate is basically the water that moves through the landfill, and it goes to wastewater treatment plants to get refined and cleaned. And so in Kent County, we built a pipeline from Sandtown to the wastewater treatment facility, which is like over near Lipstick, which is pretty far, but it was worth the investment because we didn't have to load it in tanker trucks and put those on the road and have these emissions. So like moving this material through pipes is a much smarter way to do it. And when last year I went to Sweden on a tour, a waste tour, and actually it was 2 years ago, it was 2020, but one of the things they're doing in Sweden is all their new buildings, every new household, every new apartment complex they build, they have a pipeline that goes directly to the wastewater treatment plant, which is so they have your typical, like what they call gray water, which is like the stuff from your shower and your sink that goes to wastewater treatment plant in a pipe. But in a separate pipe, they have the line from your kitchen sink with a garbage disposal, and that goes straight to an anaerobic digestive facility. And there's no trucking involved. So they're doing all of it through moving with pipes. So they're not, a truck does not have to drive through their city and pick up their food waste. They're putting it all into this bigger garbage disposal, and that is grinding the food and putting the food into the pipe and into the anaerobic digester. So this is just kind of like the next level thinking with this. It's like trying to avoid the collection of trucks. Now, the problem is that cities are much smaller. They are built, when they're building something new, it's easy to do it. And in the United States, like our infrastructure is much larger. Like large cities like New York and Philadelphia and all our major cities would have a really hard time building a whole new piping system, right? I mean, that would be a really large undertaking. But in new development areas, which more rural areas, it's definitely a possibility.
Can I ask you a related question? And there's been some chatter in the chat box about it too, is what ultimately happens with it? It's when you do backyard composting or community composting, it ends up back in the garden. as
Mhm.
soil and fertilizer. So this is not though, is it?
No, right. So, but so what Mike was saying is like if we had another place to take it, like a anaerobic then you could create a compost material from the digestate. So the
Yeah, but then
digestate
it
could
wouldn't
be-
go down the drain.
right. It
would
wouldn't
just-
go down the drain. It would go to one of the. But in this,
But right now, the sewer system is,
correct. It's going
Oh.
in the sewer system into the wastewater treatment plant. It's being treated. They are capturing again. In Wilmington specifically, they have an anaerobic digester there, so they are capturing the gas, but everything else is going through the system and out into, and it's being discharged once it's clean. So there's no compost material that comes out of it, but it is treated, and it is obviously
a
discharged.
stupid question though, where does it go?
It goes in the river. I mean, just like all the wastewater treatment facility discharge, it goes the same place. So, it's discharged into the Delaware. Once it's clean enough and it's water quality, it goes into the Delaware River.
Okay, a stupid question, I didn't know that.
Yeah.
Helen's been waiting patiently.
Yeah,
I have, wait a minute. I have been waiting patiently. I live in a retirement community just over the line into Pennsylvania. It's called Kendall. Some of you may know about it. And we've been looking at various composting possibilities for our kitchen. There are about 400 people who live here and are, provided with meals. We have our own wastewater treatment facility here. I just wondered if you could say something about the feasibility and maybe the cost of putting a program like this in, if you have any thoughts.
I mean, I would say, 400 people is probably a low amount for this. So, but they do have smaller they do make smaller systems that you don't have to, because I don't know like how much you generate. I would need to know like some specifics, but it's possible. Yeah, sure. I mean, it's definitely possible if you have an on-site treatment facility that you could.
Would it stress that facility greatly? I mean, there's a huge amount of waste it's appalling. It's not just food that's left on people's plates, but they throw away tons of food every day because
Right.
you can't, reserve it.
Yeah.
So I forget what my question was.
You were wondering if it'll overwhelm. I don't think it would overwhelm.
Yeah, thank you.
And-
for
and the cost, Ellen, were you wondering just an approximate cost of
yeah, sort of.
implementing?
Well, yeah. Do you have any idea?
The
Because
small units cost, so I mean, Tower Hill doesn't have a huge student body, so they were a smaller one, but they pretty much fill to capacity every day, the digester. Cesar Rodney is a huge one, and theirs actually keeps up with the thousands of meals. We think they may be the largest point source food waste in the state of Delaware. So the cost of these, roughly the smaller units, they're about $26,000. But that's where we're hoping, if there's a grants program that can help people get them more inexpensively. I think Mike's right that the savings over time, you don't have to dump them. So food waste is heavy, you pay tonnage, you'll probably be paying less tonnage, even though you still have waste. So you save that. For a school, we can use multiple uses, and there's a huge, for some of the schools, certainly a huge PR value to be doing something environmentally conscious. It could be for a residence that's trying to attract residents and say, look, we're doing something more, And then just to clarify on the question about fertilizer. So the uses that people are looking at is you take the waste, you put it in an anaerobic digester, you get out biogas that you can sell, and then you also can get fertilizer out of it. So EV Tech has been working on how to get a fertilizer product as well. And if you can get both of those out, I think you have a pretty economic system.
So Mike, they could do it and not have it go to their wastewater treatment plant. They could, like you were talking about, they could do it and then keep it out of the waste stream, but just use it for fertilizer and soil, right?
They'd have to do something to it to make the fertilizer, but yeah.
But not, okay, but like compost.
It would
Right.
have to go, it would have to go into some sort of like windrow type of facility.
Okay.
You'd have
It would
to
need
dry it
another step.
out. Yeah, it would take some doing. It's not easy. Like it's a process. Like you would
Okay.
need someone that knows what they're doing on how to process that. It's not it's not something you could, it's not like backyard composting. It's not that
Okay.
simple.
I
Yeah.
wouldn't advise you do that yourself unless
Yeah.
you're set
Okay.
up. Better if you could, and hopefully it might,
Do it yourself.
if there were industries that came up and it started to be more, then, people are paying for food waste now. They're buying food waste because
Yeah.
they have a facility. So if there were facilities around, someone
Right.
might do a little bit for it because they have anaerobic digestion is very finicky. So you need like someone doing that who knows what they're doing. And we're trying to, the composting, as Mike said, is smelly, and to lay things out may not be what you do.
Ellen, I would just say because you're in Pennsylvania, you would qualify probably for Mike's grant program, but from my work in Pennsylvania, my guess is that the Pennsylvania Environmental Protection Agency might actually have grant money. They have a wide array of grant monies available for things like this. And my guess is that they might have some money that would at least offset some of the cost of implementing.
Okay,
And
good.
if
Thank
you
you.
contact me, I can try to Google that for you if you want help.
I would love help. Thank you.
Yeah.
Thanks.
And there are some larger, there are some successful composting facilities in that area in southeastern Pennsylvania, especially like up near Mannheim and Lancaster. There's at least 3 facilities I know of that are pretty successful in managing food waste and composting.
Would you be
Okay.
willing to put the names of those on the chat if you know what they are, or at least?
Yeah, I'll have to, I could email Dee. I don't have them,
Okay,
but I'll get them for you.
that's great. Thank you.
All right. Dave, you have your hand up.
Yeah, I guess sorry. I shut my camera off to make the hand more visible. I'm just back to this question about the end result of the compost operation winding up in the river. Maybe I missed something, but wouldn't the extra nutrients contribute to eutrophication and other kinds of problems just by adding, I think maybe Fred or somebody put that in the chat already. But I thought, Mike, when we were doing the MRF tour, you said something about extracting the food components from the wastewater stream and diverting it to land application someplace. And I'm sorry if this is repetitious. I had to step away for a minute.
Well, there's 2, I guess there's different wastewater treatment facilities in Delaware. So they all have a little bit of different, for Wilmington specifically, they do release into the river. So, but there are some, like in Kent County, there's still some land applications that they use for this material. I think that even in Middletown, there might be still some land application in the fields by their park, I think in Levels Park. But yeah, so it depends on the facility. They all do different things. But yeah, the nutrients are going to be in the water to some degree, but the treatment facility is taking out most of the load that's going to, so once in order to discharge the water, it has to meet the requirements, so it's safe to go into the river. So it's not like that would not change. The discharge would be the same as it is today, with or without this material going in.
I could just throw in a comment. I know that this kind of stuff is not very very applicable to backyard experimenting, but we're living on several acres out here, and I created windrows at one point along the lines of the Wildlife Federation's recommendation to have stick piles, to try to create extra wildlife habitat. But in my stick piles, I just ran a ramp up to the top of these things and wheelbarrowed stuff up to a height of about 8 feet. And everything went in there, leaves, our food, our kitchen food stuff. We're plant-based. So, I mean, it wasn't like we had a lot of meat going in there attracting rats or something. But, a whole bunch of stuff went in there. And I noticed that winter by winter, that pile, sticks and all, would sink down about 2 feet. Just every winter, it would just collapse on itself because of the composting it was doing. And I got the idea from somebody I know in Ursuldune who had just been throwing her sticks and leaves in a pile for 15 or 20 years. And that was the we were taking stuff off the bottom of that pile. It was just the blackest, richest, most friable stuff you could imagine. It was just, it looked like gold, or, earth gold. It was great. Thanks.
Yeah, I mean, that's the beauty of nature, right? It takes care of itself. Like, it's not like, I think that's one of the biggest misconceptions about composting is like, it happens every day in nature. Like the stuff that's falling in the woods is composting itself over and over and over again. So like leaves and sticks and all those things, they do decompose. So yeah, and yeah, you're right. Like you can just if you live in an area where there's no neighbors and no like, you can do that. You can just put it out in the field and it'll decompose for sure.
Yeah, the other thing about our piles was, and I think this is true of Longwood Gardens too, I put it in the chat, they run a very sophisticated composting operation, including a lot of woody materials that they grind up, I think. And there's no odor from the adjoining land. And in South Chester County, there would be complaints if there was an odor out there.
Yeah, for sure. Yeah, I mean, adding the food waste to the leaves and the grass and the sticks and the ground wood, that's where you introduce the most potential for odors. But if you do it the right way and you turn the pile on a good frequency, you can minimize the odors. But a lot of it's just where are you located and who are your neighbors and how close are they to you? And like the best managed compost facility in the world, if you walk straight up on the pile, you're going to smell it, like because it's decomposing. Okay. So I don't care how well you do it, you're still going to have a smell. Now, the problem is not everybody does it perfectly. And the problem is like even if you did do it really well, you might be just too close to other people where they're going to get that odor. And also depends on which way the wind's blowing, the barometer, the pressure, all those things factor in. So it's not just a simple solution.
I have a question for you, Mike, and not to put you on the spot, but I've been curious about this question, but in a broader sense. But if food waste is 25% of what comes, say, to Cherry Island or whatever every day, and you said that even if we had, say, 30 of these out there at the largest institutions, it would take up a pretty significant portion of that. So then what happens to the DSWA model of your income, for instance, and revenues, if all of a sudden, let's say 20% of food waste went away?
Yeah, no, it wouldn't be a big problem. I mean, the thing that I think the biggest misconception people have about the authority, and the reason that a statewide authority or a countywide authority is favorable over a private sector, we're nonprofit, right? We don't have to make money. Like all we have to do is break even. And so like if we have to manage a million tons or 500,000 tons, the cost is, there's a sliding scale. In other words, it costs us less to manage 500,000 tons than it costs to manage 1 million tons. So when that happens, and it has happened, I mean, we went through a situation in 2008 where the waste dramatically reduced, and it wasn't because anybody did anything great in terms of diversion or recycling or anything like that. But what happened was the waste went from 1.2 million tons to about 600,000 tons. And we're still here. Like we didn't go bankrupt because we adjusted our operations to that amount of material. And you may or may not have to adjust the price because but we have that ability to adjust the price when necessary. And so it's not a problem. Like we can expand and contract as an organization to manage the waste. We want less to manage because we want, the other thing on when you talk about cost is one of the biggest costs from DSWA isn't the day-to-day management of waste. It's the post-closure care of facilities when they close. So if we were to close a landfill, you have to take care of that landfill forever. So the cost of that is tremendous. So like it's hundreds of millions of dollars. So that's the material, like that's the cost structure. It's not about the day to day. So if we can make that landfill last an extra 20 years, that's a tremendous cost savings, way more than what it would be to not get 50,000 tons or 60,000 tons of material. It's not even close. So for us, it's always better to extend the life of the landfill, because to site a new landfill, well, I think it would be almost impossible to do in Newcastle County. But even if we could, the cost would be $400 million, $500 million. I mean, just realistically. So it's not something we really want to do. So it's a good question, but it's also a common misconception that like if we lost tonnage, we would be in some financial strain. No, it's just not true.
Good to know. Good to
Yeah.
know. Greg, I see you have your hand up. Where'd he go? No. Oh, Greg, do you have a question? No.
Yeah,
Okay.
sorry, I wasn't unmuted there.
Oh, there you go. Okay.
To kind of go along the same lines of what you're talking about, and I think just to clear up some of what's in the chat, Mike, can you kind of explain the difference between, obviously that the landfill is anaerobic, but the difference between a landfill anaerobic and an anaerobic digester?
Yeah.
Kind
So
of how things are captured in an anaerobic digester and
Yeah.
not as much in a landfill.
yeah, that's a good. So landfills, in a way, there's decomposition that happens in a landfill, right? But they're not designed for decomposition. So a landfill is a cell, and it's supposed to be, it's supposed to not let water and oxygen into that cell. But we all know it's imperfect, so it happens. So different parts of the landfill cell will break down because there's decomposition that happen because air and water get into the cell and it starts to decompose. But the idea of a landfill is to create a cell that doesn't decompose. That's the whole, it's supposed to be like a tomb to keep the waste material. And in fact, it does work to the sense that you can go to a landfill 30 years from now and dig up a cell, and you will inevitably hit a part of the cell that wasn't touched by water or air. And you could pull out the newspaper from 30 years ago and read it like it was in there yesterday. And we've done this. I mean, we've mined cells. It does work. Now, there's also going to be a part of that cell that air and water got into, and it all decomposed, and you can't read the paper because it's gone. And it's just like Dave was saying, it's like black compost in there, like really. So when that decomposition happens, we have wells, gas wells all throughout the landfill that are collecting gas. And that gas is taken to the gas facility where it's used to make energy, used to make electricity. So the difference between a landfill and an anaerobic digester is the anaerobic digester's sole purpose is to capture the gas and decompose it. They want to add water, or some anaerobics, no oxygen, but add water, add heat to digest that material. Then they have aerobic systems where they pump air and they pump water into to still capture the gas. So you're capturing the gas, you're extracting it, you're burning it for electricity, and you're making, a renewable energy from it. That's an anaerobic digester versus landfill. They both do similar things, but the landfill is really, the gas is a byproduct that isn't intended, whereas an anaerobic is the sole purpose is to collect the gas and get it to and make energy from.
I put a little EPA site in the chat, which sort of gives a nice description of the anaerobic. It's really sort of an industrial commercial process. And you see there they have food waste, and our belief is that actually the pre-aerobically digested food waste will help it produce more biogas than if you just jump in the raw food waste. So treating it with the enzymes makes it more bioavailable. So that's the idea, that instead of, they're usually on farms, they put manure in there. We have some around the area that generate, electricity from the biogas that they produce, but they need to be run in a controlled environment, kept at the right temperature. And so it's not, I just want to stress that all the stuff we're doing is trying to actually avoid composting, because of the issues that we had with composting. Once you compost, you have odors, and you do have to deal with the compost material, which is fine for a household. But the University of Delaware has found that when we start composting our clippings and grass stuff, we generate so much, we can't figure out how to deal with it. There's not enough users of it. So we're really, none of what we were talking about is you stick this out in the open and let it compost in piles and things. That's not what we were after, because I think the information we got from Mike in DSWA is that, that didn't work on a large scale here in Delaware. How do we get sort of a more point source solution to food waste? But I mean, it's wonderful if people at home are composting and using it for their gardens, or
Yeah.
small entities do that. There's no problem with that. But as you start getting to a larger restaurant or other things, you start generating enough that trying to have them set up composting that doesn't create problems is not what we were after.
And this is exactly what's happening in California right now. So California is doing these large scale projects, and they're creating tremendous amounts of digestate, and they don't have an outlet for it. And it just sits and sits and sits in fields, and it rots, and it just rots away. And the reason is there's two main problems. And what Mike is talking about is, they're putting whole food into these digesters. It's not been broken down like what we're talking about. So that material is coming in very heavily contaminated. And because it's being collected at the household level, it's being collected commercial level, and it's coming in with glass, and it's coming in with plastic, and it's coming in with all this contamination. And so they still process it, and then the stuff is into its digestate form. And when I went and looked at those piles, and they take it and they cure it, they put it out in windrows, and you walk down those aisles, and they glisten from the sun because there's so many glass particles in the digestate. You could see it was visible. It was visible from the naked eye to say, there's a lot of glass in this pile. And they try to filter out the glass, but at that point, it's just too late. You can't get the glass out. And so what they found is, like, they had plastic and glass in all their digestate, and nobody wants to use that for their home garden. No one's going to buy it. No one's going to put it in their garden. They couldn't sell it commercially. Farmers didn't want it. So they bought farm fields in Gilroy, which I'm talking about. They're taking from San Jose to Gilroy, which is far, and they're just dumping it in fields, and it's just sitting there rotting. And because they have no other alternative, they don't know what to do with it, and they don't want to landfill it because it's kind of defeating the whole purpose. So it rots and it decomposes. But what happens is, what's left behind is glass and plastic. Like, the organic stuff's going to go away eventually, but the glass and plastic's not. It's going to sit there in the field. And so now they've contaminated, in my opinion, they've contaminated these fields. So yeah, it's Mike's right. Like, if everybody did it, we'd have too much of it. But it's great on a small scale. If you're doing it at home and you're using it, that's perfect. That's exactly what we want people to do. That's why we're really targeting the large generators in this program, so we don't have this abundance of digestate to have to deal with. And it avoids the odor situation, which is another problem.
Okay, Dave?
I have a fantasy question for Mike, looking to the far future. Are we ever going to get to a point, maybe in our lifetimes, where, there will be millions of little micro robots with little scoops and tweezers and bags for gas collection and liquid collection, scurrying through the landfills to reclaim all these little bits of materials and, take out all the glass particles and things like that?
Yeah, well, I mean, I don't know about the robots, but I will say, like, mining landfills is not a concept that is foreign. Like, people are doing that right now. So Worcester County in Maryland ran out of landfill space. So they were, many of you might have read this many years ago, Ocean City, Maryland ships all its trash to Chester, Pennsylvania, to the incinerator. And so they were like, we're out of landfill space. We need a place to take it. So that's what they build a transfer station. They transfer everything from Ocean City to and they basically said, we're not going to do recycling anymore. We're just going to put it all in. We're going to burn it all. And that was their solution. Well, then, people started to get upset about this and complain. And so they were like, okay, well, what do you want us to do? Well, you don't have any more landfill space and there's nowhere else to put a landfill. So what they did about 4 years ago, they started to mine a cell. And what they did is they basically did what I was talking about. It was an old cell. It was about 25 years old. They went in, they're digging it up, and they're actively taking the stuff that's in there the plastic and the metal, and they're recycling it, and then they're taking the nutrient ground, they're sifting it, they're sorting it, and they're rebuilding on that same footprint. So that's their goal. Now that's going to take some time, and it's super expensive, but I think at the end of the day, long term, Dave, probably looking real futuristic, that's probably the answer to footprint problems. Like if landfilling, if we're still landfilling 100 years from now, in my opinion, we will be using the same footprint that we currently have and just doing these because I don't see the possibility of these places, especially if you look at New England and the density of population there and the way that they just have no place to put landfills and they're running out of landfills. Like if landfill is the solution still, then they're going to have to use the footprints that they already have because there's just nowhere else to put new places.
On a related point, and to make a plug for the MRF tour, if there's anybody here who hasn't already been on it, I was really impressed at some of the separation technology on that tour. You know, that you can, like, it was amazing that they're, you know, that machine, those machines can tell the difference between one number plastic and another number plastic using lasers and little puffs of air to separate them on a different conveyor belt. It's just, for me, it was mind boggling. So thank you.
Mm-hmm. Yeah, no, it is. You don't have to thank me. I didn't come up with any of that technology. That's not, I don't have anything to do with it, but no, it is amazing technology. And I'm very happy that we have a company like Republic that invests in the MRF. As far as they have 5 ocular sorts, most MRFs only have 1 or 2. And they also have the robot, the AI robot, which is sorting material, which most MRFs haven't made that investment yet. So we're very fortunate in Delaware to have an advanced MRF. And it allows them to do things that other MRFs can't do with plastics. Like right now, we are one of the few MRFs on the East Coast that are selling 4 and 7 mix plastic. Like hardly anybody's doing that. But our stuff's so clean, they're willing to buy it. So it is good that our material is getting to market. But you know, the older MRFs, they can only do one, 2. That's it. That's all they can do is sort it, and they can sell that, but the rest of their plastics really not getting recycled.
And Stacy's been on maternity leave, but we'll probably schedule, you know, another tour or 2 in the coming months, if maybe in the spring or, you know, when it's still kind of cool out, it's better to go. So maybe in March or something like that, we'll get another one scheduled and announced. So Michael, you have your hand up.
I do. I actually had a question on the other side of it. Since Mike and I are both busy, we don't always chat. So this is like an informational thing as Rachel and I were talking. So you mentioned Keep America Beautiful, trying to partner with them. What does the timeline prospects? I actually had to reach out since Tower Hills is not necessarily their digester right now. They'd love to buy one. And so do we know anything about possible grant?
So we're just
And I just want to say Julie Merrowenger is on the call.
So Julie's the executive director, Keep Delaware Beautiful. And so I'm working with her right now, and we still haven't reached a final agreement, but we're working the details out on how we can implement this program through them. And you know, they have a lot of outreach, so they can help us reach the you know, the facilities that we want to, you know, take this on. And so we think it's a good partnership from that perspective. But we don't have, to answer your question, we're just starting this, so we don't have all the details yet, but we're working on it.
Is there any? They're probably not, but I was, you know, I was on this call today with the sustainable energy utility, and there is. And then even before that, I live in a condominium. We're looking at how we put in EV charging stations in a multi-use facility. And there's so much money's around at federal level, other levels. So I didn't know if there's any possible you know, I'm sure Julie knows better as to how to leverage different opportunities to put together a nice package, because there seems to be a lot of overwhelmingly amount of information of possible funding sources out there.
Yeah, I think that's one thing that they're really good at, is finding that money and looking out for other grant opportunities for their programs.
But we appreciate you. It's wonderful. I hope it comes about and it works out well.
I've totally lost track of the chat. Are there any last questions for Mike? I don't know if we've covered everything that's in the chat or not, but raise your virtual hand if you want to ask. There you go, Fred, your real hand.
Yeah, so it disappeared in the many pieces of the conversation. But I'm wondering, at what point do you think we'll start mining our landfills?
I mean, for Delaware, it will be a while because we still have some pretty good landfill space. So, and also you have to, in order to mine a landfill cell, it has to be a certain age. So you wouldn't mine a cell until it's at least 25 to 30 years old.
Wait, define mine. I'm thinking of,
Mine
There's-
meaning you
there's a
dig,
lot-
dig through the dig, like open the cap, go into the landfill and pull out what's in there, recycle it.
yes, okay.
Yeah, that's basically how mining a landfill cell works.
Why is more age beneficial?
So you want to let any decomposition that's gonna happen first.
Okay.
And then generally at the end of a landfill life, that it did, like right now, there's a closed landfill at Pigeon Point, right? So that's been closed for quite a while. It's generating extremely low amounts of gas because almost all the decomposition has already taken place that's going to take place. So once you reach that point, you can say, okay, now it's safe to open that cap. We're going to go in, we're going to find the stuff that hasn't decomposed. We're going to take it out. We're going to recycle it. We're going to screen the soil. We're going to test the soil. We're going to use soil where we can to rebuild the cell. And then you can start adding material back in. So, this is all, it's been done. It's not like it's never been done. It's just,
Good.
it's an expensive proposition, but it's generally done when you've run out of space. So we're not to that point yet, but I think we probably have somewhere between 30 and 50 years at Cherry Island, depending on some factors, but we have well over 100 years of landfill capacity in the state.
I was basically thinking in terms of Mother Earth has run out of copper.
Mhm.
And we're going to Alaska and other places and destroying
Yeah.
very nice environments when we've got all kinds of motors and stuff that live in a mineable state. And they got a lot of copper, might be a whole bunch of lithium there, might be a whole
Yeah.
bunch of XYZ that we really need.
Yeah, no, there's certainly precious metals in landfills for sure. I don't think it's an overwhelming amount of metal because a
Yeah,
lot of
there's a
metal
lot
has
of
been
trash
extracted, but it's there for sure. Yeah.
Okay, thanks.
Dave, you have your hand up again. Where'd you go? You there? You have there you go.
Dave wants to know about wedding rings in the MRF. I do highly recommend that video that your people put together, Mike. It's really fun. So I put it in the chat. It's really
Yeah,
fun
that
and-
we do have an information. If you didn't get to go on the MRF tour and you want to check out the video that Mike's posted in the chat, it's it kind of step by step takes you through the MRF and how it works.
in a very fun and enthusiastic way with some employees. So
Yeah.
it's
And
nice.
then as far as like, I get this question quite often. So I don't know that anyone's ever found a wedding ring at the MRF, but I will say we find things from time to time. But one of the things that happens a lot, and believe it or not, we've had some success. We've had people who have lost a wedding ring in their trash and called us and knew which trash truck it was in. And we actually found the wedding ring. That happened twice.
Oh.
So at the landfill. So if you've ever been to the landfill and you see the mass of trash that's there and you think, how did anybody find a wedding ring? It's happened twice in my time at DSWA. So in about 20 years, it's happened twice, but I can say there's been a lot of other things that have never been found that people have called about.
Oh, Mike, not to beat it to death, but it might be worth getting a grant to do a pilot just to see what you might find if you did the
So we've done
Landfills
test
either.
mining before. So we have done it in the past at Sandtown landfill. So we have a pretty good idea of like the material that's in there. And keep in mind, the reason you do a mining is not so much for the extraction as it is to generate more space for future landfill cells.
Sure.
So that's the real economics behind it. The economics probably wouldn't work if you were doing it just on a mining expedition to see what you could get out of it.
So, okay, so people throw out vacuum cleaners and XYZ things that have motors in them.
Mhm.
Has there been any consideration of landfilling those in a separate place for future mining?
So if it comes in, it depends how it comes in. So if someone throws a vacuum cleaner at the curb and it comes in a truck, it would be really almost next to impossible to separate that out.
Right.
But if someone brings it in themselves, we have like what we call a white goods or scrap
Yeah.
metal area.
I know it. Yeah.
And so that material is kept separate and never really goes into the landfill. And if a vacuum cleaner ended up there, it would go to our electronics recycling program. So we wouldn't landfill that at all. So we don't. So the only way something like that gets into landfill is if you put it in your at the curb and the trash guy puts it in the back of his truck and then it gets to the landfill. It would be really impossible to kind of pull that stuff out on a day-by-day basis because there's so many trucks and there's so much and to have people go through the trash is not safe on a day-to-day basis. You wouldn't want people rooting through and pulling things out. It's just not practical.
Oh, well. You're right.
All right. Well, it's by my clock almost 1:15, and I try to promise everyone to be out of here by 1:15. So thank you tremendously to Mike Parkowski. I think everyone was really intrigued by this conversation and to learn more. So maybe we'll look forward to an update in a year or two to see how it's going.
Absolutely.
And a bonus thanks to Mike Chages for being here too, to answer even more questions. So that was great.
For coming. That was great, Mike. Thank you.
And Rachel, you too. I know Rachel was busy over in the chat providing lots of information. So Nora, I see a hand up. You have one last minute question real quick?
I think that's a clap.
Oh, okay, sorry. Thank you, Nora.
Thank you, Dee, for putting this together.
All right. So thank you, everybody, again. And it was great. Mike, thanks. And we'll look forward to an update.
All right. Sounds good.
All right.
Thanks, everybody.
Take care, everybody. Have a great afternoon. Bye.